Okay, welcome back to math class. Up next in our little adventure with exponents that we've been going on in chapter 9 is we're learning what happens when you need to find the power of something that already has an exponent. Basically finding the power of a power. So if it looks like this, 2 to the third, and that whole thing to the fourth, now what do I do? Well, let's try factoring it out like we have been so far this whole chapter. Now I have 2 to the third to the fourth, so something to the fourth is something times itself 4 times, right? So I'm doing 2 to the third times 2 to the third times 2 to the third times 2 to the third. 2 to the third 4 times. Now if you remember back to what we talked about in 9.3 with multiplying and dividing exponents, or powers, multiplying and dividing powers, when I'm multiplying powers by each other, I add their exponents. So in this case, 2 to the third times 2 to the third times 2 to the third times 2 to the third is going to be like saying 2 raised to the 3 plus 3 plus 3 plus 3, right? Adding all the exponents up, and that's going to give me 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. 2 to the 12th. Another way I could do that is I'm doing 2 to the third 4 times. So I'm adding 3 4 times. So that's basically the same as saying 2 to the 3 times 4. And 3 times 4 is 12. So whereas when I'm multiplying powers with the same base, I add the exponents. If I'm taking a power and I'm raising it to another power, then I multiply the exponents. Let's look at a couple examples. Okay, so if I had, that was with a number, what happens if I have a variable? Into the fourth to the fourth. Well, I just take it just like I did with the 2. I could factor it all out, write all of those ins, or since I have a power raised to another power, I'm going to take n to the 4 times 4, and 4 times 4 is 16, so n to the 16th. It's as simple as that. You could write it all out, you can multiply it all out, or you can memorize any power raised to another power, you multiply their exponents. Now I know what you're thinking, what happens if one of those powers is negative? Well, you treat it pretty similarly. If I had 2 to the third raised to the negative second, I'm still going to write it as 2 to the 3 times negative 2, and 3 times negative 2 is going to give me 2 to the negative 6th, which we know is the same as saying 1 over 2 to the 6th. So you still treat the same problems like this with negative numbers the same. You still multiply the exponents, but you've got to keep track of those signs. And when you multiply a negative times a positive, like negative 2 times positive 3, your answer is negative. And when we have negative exponents, we know that that's putting our power in the denominator of a fraction. One last layer of complication we're going to have is what happens when we're raising something to a power, but what's inside the parentheses is a product of a few things. So like if instead of having just 2 to the third or just n to the fourth, what if I had 6 w to the fourth raised to the 5th. So now instead of just having one power raised to another power, I have 6 times w to the 4th. What we're going to do here is I'm going to find the power of each piece and then multiply them together. So I'm going to rewrite it like this. 6 to the 5th times w to the 4th to the 5th. Now I can multiply, go ahead and multiply 6 to the 5th out. You can put it in your calculator when it's numbers this big. And we're going to get 7,776. That's 6 to the 5th. Now I'm going to do times w to the 4th to the 5th. Now I know when I have a power raised to another power, I'm going to multiply its exponent. So this is 7,776 times w to the 4 times 5. 4 times 5 is 20. So we're going to get 7,776 times w to the 20th as our answer. Now that adds one layer of complication, but just keep in your head, you have to raise each piece to the power. All right, we're going to try one more that's just a little bit more complicated, and we'll see how we do. Okay, what if I had 3 times x to the negative 2 times y to the 4th, and all of that was squared? Okay, we're going to do the same thing that we did in the last problem, where we're going to raise each piece of the monomial to the 2nd power. So I'm going to split it up into 3 squared times x to the negative 2 squared times y to the 4th squared. So I'm squaring each piece and then I'll put them back together. All right, now right off the bat, 3 squared we know, right, is going to be 9 times x to the negative 2 raised to the 2nd again. We know when we raise a power to another power, I multiply the exponent. So that's going to be x raised to the negative 2 times 2 times y to the 4th squared. If I raise a power to another power, I'm multiplying the exponent. So I'm going to get y to the 4 times 2. Okay, now all that's left is to put everything together. Put it back together again. I get 9 x raised to the negative 2 times 2. So that's going to be negative 4, right? X to the negative 4th. Y to the 4 times 2, which is 8. Y to the 8th. Okay, now here's the last step. Looking at this, I have a negative exponent. So what I can do with this negative exponent is rewrite that x to the negative 4th as what? It's going to be rewritten as, we'll still have our 9 and our y to the 8th, right? But now we're multiplying it by 1 over x to the 4th. You see that? Because we know when we have a negative exponent, that's the same as saying we're actually dividing by that, and it's in the bottom. So when we put this together, it's actually going to look more like 9y to the 8th divided by x to the 4th. That's as complicated as we're going to get today. Okay?